An example to graph a secant function, and it's very similar to the cosecant function. For the secant function, we're really going to graph the reciprocal function of it, which is cosine. And from the cosine graph, we're going to formulate what the secant graph is going to look like. So basically what I'm going to do is I'm going to ignore that it says secant, and I'm going to first graph in what this thing would look like if it was 1 minus 0.5 cosine of 2x plus pi over 3. Alright, so some of the similar steps. This one has a translation up of 1, so I put this dotted line here for that movement of all the points on the x-axis up to this dotted line. And it has an amplitude of 0.5. It's negative, so it's going to be upside down. So it's going to go up 0.5 and it's going to go down 0.5. Alright, so the rest of it comes from taking the inside here and set it equal to the period of a cosine. So I'm going to take 2x plus pi over 3 and set it equal to 2 pi. And solve for x. So after I solve for x, I get x is equal to negative pi over 6, the translation, plus pi, which is the period. Now remember, we're going to take pi and cut it into 4 equal pieces. And in this case, it's real easy. Pi times 1/4 is pi over 4. So over here, I'm going to start my cosine function at 0. Then I'm going to do the 4 equal pieces. You get pi over 4, pi over 2, which is 2 pi over 4. This will be 3 pi over 4. And finally, we're going to get 4 pi over 4, which is pi, which makes sense because, that's the period. From this, though, I'm going to have to take away pi over 6. That's the translation. This graph is getting moved pi over 6 to the left. Alright, so 0 minus pi over 6 is negative pi over 6. Pi over 4 minus pi over 6, common denominator of 12. This would be 3. This one will give you 2. So this would just be positive pi over 12. Pi over 2 would be 3 pi over 6, so this would be 2 pi over 6, better known as pi over 3. 3 pi over 4, that would be 9 minus 2, which would be 7 pi over 4. Or, I'm sorry, 7 pi over 12. And then finally pi would be 6 pi over 6, and we lose 1, so this will be 5 pi over 6. So these would be the 4 equal cuts. So here's negative pi over 6. Here's pi over 12. It's just 1 dash. Pi over 3 is right here. And so far it's making sense. It's 3 units in between each one. 7 pi over 12, let's see, this would be 1, 2, 3, 4, 5, 6. It would be here, 7. And notice there's 3 units between this one also. And then 5 pi over 6, which is here. So our points for cosine, cosine usually starts high, but in this case it's going to go low. Now, what I mean low is it's going to go the amplitude down from the middle line. So it's going to go here. And then it's going to go middle for the next mark. It's going to go high for the next mark, back to middle for the next one, and back to low for the last one. And that would be the start of our cosine graph. It looks something like this. I have a better picture in my next slide. You get those 5 points. Alright, so our cosine graph is going to go through this, and if we fill it all the way out, the cosine graph is going to look like that. For secant, though, since secant of theta is equal to 1 over cosine of the angle theta, what's going to happen at these intercepts of the x-axis that was translated up is we're going to get vertical asymptotes. So we're going to get a vertical asymptote anytime this thing crosses the middle line, which would be here, here, and I'll put this one in over here, and this one back here. Ooh, missed it. Here. Alright, so what's going to happen is these are vertical asymptotes, and since it's a reciprocal, the smallest value is going to be -1, and 1 over -1 is -1, so we get that point. But as we move this way, the value gets smaller than that, and therefore the reciprocal of it's going to get bigger. So this cosecant graph is going to approach these asymptotes in this fashion. And that's why it makes it kind of easy with all this information in here. So we get these things going away from the x-axis. Kind of like little parabolas, but they're, bounded on both sides. So that is how you graph the secant function. As you first graph the cosine function, where it crosses the middle line and or x-axis, you draw vertical asymptotes, and then you draw little parabola thingamajiggies on the inside. That's it. And the same thing works for cosecant. You just graph the reciprocal function, which is sine, and then do the same thing where it crosses the middle line, draw vertical asymptotes, and little parabola things.